Today, we've got an exciting piece of news coming from the University of Maryland. Researchers there have taken a significant step in shedding light on how the building blocks of life might form in space. Under the leadership of chemists at the University of Maryland, a team has discovered a new way to create carbons, a class of highly reactive but short-lived and unstable molecules. Now, why are carbons so important, you may ask? Well, carbons play a crucial role in many high-energy chemical reactions, like the formation of carbohydrates, which are essential precursors to life on Earth and possibly in space. Scientists successfully created a carbon called hydroxymethylene by breaking down methanol, a common alcohol found in many industrial chemicals with pulses of ultraviolet radiation. Assistant Professor of Chemistry and Biochemistry at UMD, Leah Dodson, stated, "It's surprising to see that this carbon came from a simple molecule like methanol. We're used to seeing it in bottles all over the lab." Dodson added, UV lasers with a wavelength of 193 nanometers are also quite standard. This means that carbons could naturally form in places like space where there's plenty of methanol and ultraviolet radiation. And through this process, the carbons formed in space could lead to further reactions, potentially giving rise to the biomolecules that make up life. Due to their superreactive nature, the lifetimes of carbon molecules are often very short, making them challenging for scientists to produce and observe. However, the new method developed by the UMD team for producing carbons has allowed them to closely examine the formation and decay of these molecules on timescales of milliseconds. When researchers discovered that HCOH reacts relatively slowly with oxygen at room temperature, they were surprised. Researchers believe that the methods for producing and studying carbons will help astronomers and astrochemists gain new insights into the origins of life and how life in space may have evolved differently from life on Earth. By taking a closer look at what happens during the breakdown of methanol and measuring the different products that result from methanol's reaction to UV light, they hope to refine their findings. Understanding the types and quantities of products produced when methanol is broken down by UV radiation will provide astronomers and astrochemists with a more accurate perspective on astronomical objects and how they've evolved over billions of years. Dodson remarked, "If the current data on what's produced from methanol photodissociation is wrong, then the models we produce will be wrong too, and our understanding of how life evolved from these molecules could be at risk. We hope that our follow-up studies will form the basis for these kinds of simulations." In conclusion, this exciting discovery from the University of Maryland represents a significant step forward in understanding the origins of life in space. The mystery of carbons seems to have been illuminated a bit more, bringing scientists one step closer to unraveling the secrets of life in the cosmos. Keep tuning in to Science and Space News for more updates on these kinds of discoveries.